Hello everyone, welcome to the Code Odyssey. I'm your guide through Rust, one of the most loved and most misunderstood programming languages out there. Let's get into it. There's a single character that causes more confusing errors for new Rust developers than almost anything else in the language. It's the semicolon. By the end of this video, you will never be confused by it again. And we'll cover every loop type, functions, and a full FizzBuzz project together. Let's talk about expressions versus statements. This idea is small, but it explains a huge amount of confusing errors you will hit later. So let's take it seriously right now. Let me first open main.rs and here the function. A block in Rust can produce a value, and that value is whatever its last line evaluates to, as long as that last line has no semicolon. Here the block assigned to y ends in x plus 1 with no semicolon. So the whole block evaluates to 4, and that's what gets stored in y. So let's run this program. Cargo run building, and here it is, y is equal to 4. Now watch what happens when we add a semicolon where we shouldn't. Here's another function, add 1, and this will not compile. Let's try, and here it is, mismatch types expected I32 found parenthesis. Here's exactly what happened. The function promised to return I32, but that semicolon turned x plus 1 from an expression into a statement, and our statement produces nothing. Technically, the empty value written as a pair of parentheses. So the function's last line now returns nothing instead of the number we wanted. Remove the semicolon and it compiles immediately. So let's first of all we need to use this function. So let's print ln and add 1. So this is good. So cargo run, and here you can see here add 1 5 is equal to 6. Keep this rule locked in for the rest of this series. The last expression in a block with no semicolon is what the block actually returns. Let's continue to functions. So let's look at functions properly. Here we have 3 functions, main, add, and greet. So add takes 2 I32 parameters and returns an I32, and notice no return keyword needed. The last expression a plus b is automatically what gets handed back, exactly the rule we just covered. Greet takes string slice and returns nothing at all, just prints. Function parameters always need explicit type, even though let usually guess types on its own without you specifying them. Why the difference? A function signature is a contract, both for you and for anyone calling it later, and contracts shouldn't depend on guessing from how the function happens to get called. Let's run this, and the expected prints 5 plus 1 equals 12 and hello class. So let's continue one more pattern. An early return. So what happened in this function? If n is negative, we explicitly return early with the negative value. Otherwise, execution falls through to the final line n, which is an implicit return, exactly like before. So let's try function main and print an absolute value. So first of all, we passing the negative value -3. Let's run it, cargo run, and here it is. Absolute value of -3 is 3. So it explicitly return negative value. And what happened if we pass the positive value? And obviously it will fall through to this implicit return, and you can see here 3. As we have -3, so it's showing here -3, otherwise the expected output. Now if and else. Here the first part is if else, exactly how you would expect from any language, checking whether number is even with the modulo operator. But the second part is interesting one. If is also an expression in Rust. We assign the entire result of an if else directly into description. And the only rule is that every single branch has to produce the same type. Here both branches produce a single slice, a string slice, so it compiles cleanly. So let's run it, cargo run, and here is expected if and else prints. So here we have 7, so obviously this is odd number and it is saying 7 is odd. And here description, so number is greater than 100, so big, so obviously number is 7, so it is small, so 7 is small. So the output is expected. So let's take that further with a great calculator, and here is a new function main, a whole chain of else if, and the entire thing collapses into one clean assignment to grade. With a score of 85, we fall into the second branch and grade becomes B. So let's run this, and here it is, grade B. Rust gives you 3 different loops: loop, while, for, and each one has a specific job. Let's see all 3 in one place. First loop, it runs forever until you explicitly break out of it. And here's the genuinely unique part. You can break with a value, break counter stat2, and that value becomes the result of the entire loop expression. We count up to 10 and then break with double that, so result ends up being 20. Next, while, it runs as long as condition stays true. We count remaining down from 3 to 0, printing each step, then lift off once the loop ends. And for, your default choice, whenever you already know what you are iterating over, 1 dot dot equals 5 is an inclusive range. Notice the equal sign. So it includes both 1 and 5. without the equal sign, like 1 dot dot 5 would stop at 4. And for works directly over collections too. Here iterating straight over an array, fruits names, no indexing required. So let's run this program. Result equals 20, 3, 2, 1, liftoff. And here 1, 2, 3, 4, 5. And finally, I like apple, I like banana, I like chair. So which loop should you actually reach for? Use for when you know what you are iterating over a range or a collection. That's your default. Use while when you are looping based on changing condition rather than fixed sequence, and use loop specifically when there's no natural end condition, especially when you want that break value trick to hand the result back out. Let's continue to the project, but before continue, here we have 3 exercises you can practice. Number 1, write a function as even, taking an i32 and returning a bool, and call it inside an if else that prints even or odd. The second one, use a while loop to print the numbers from 10 down to 1, then lift off without using .rep. This is a internal function, so we will cover it later. Since you haven't seen that yet, just count downward manually. Third one, write a loop that adds the number 1 to 3 and so on together until the running total exceeds 50. Then breaks and returns that total and print the result. Okay, so continue to the project, which is FizzBuzz, and a twist on this classic FizzBuzz exercise using everything from this chapter. So first of all, create a new function which we called it FizzBuzz, and here we taking a parameter which is i32 and returns a string. Let's use if n percent 15 equals 0. So a string colon from FizzBuzz. Else if n percent 3 equals 0. So string colon from fizz. Else if n percent 5 equals 0. String colon from buzz. Else and toString. So what happened in this function? Inside that function, we check divisibility of n by 15 first, since that covers both 3 and 5 at once, then 3 alone, and then 5 alone. And otherwise just convert the number itself into a string with toString. Notice every single branch of that if-else if chain returns a string, satisfying the function's declared return type and using the implicit return rule from the start of this chapter, which is not using the semicolon. And let's use this function in new function, which is main empty parenthesis And here we use the for loop for n in 1 to let's say 30, and print ln independent. Okay, perfect. Let's run it. So here it is: 1, 2, fizz, 4, buzz, fizz, 7, 8, and so on. And finally the FizzBuzz, and here is FizzBuzz, which is the divisible to 15. Here we loop from 1 to 30 inclusive. Here we use equal sign, so it is inclusive, calling FizzBuzz on every number. So that's it. Going further, modify the program so it also counts how many fizz, buzz, and FizzBuzz results occurred in total, and print that tally at the end. Give that a real, genuine try before moving on. To summarize this chapter, a semicolon turns an expression into a statement discarding its value, and that's the most common source of mismatch types errors for beginners in this entire language. Function parameters require explicit types, return types follow an arrow. If else can be used as a genuine expression, not just a statement, as long as every branch produces the same type. And for is your default loop for known ranges or collections, while is for condition-based looping, and loop is specifically for when you need break to hand back a value. That's it. If this helped, subscribe. We have got a long road ahead and I would love to have you with us. See you in the next video. In the next chapter, which is chapter 3, ownership, where we cover ownership, the single idea that makes Rust Rust. This is the one chapter in the whole series I would genuinely ask you not to skip or skip.